We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives.
It is a wonderful and astonishing thing to me that we are, you and I, are somehow at least one of the ways that the universe knows itself.
Those worlds in space are as countless as all the grains of sand on all the beaches of the earth. Each of those worlds is as real as ours. In every one of them, there's a succession of incidents, events, occurrences, which influence its future.
We are special because we're the same. We are one, not only with each other, but with the universe itself.
I know Hamlet, and what he might say with irony, I say with conviction. What a piece of work is man! How noble it is, how infinite in faculty, in form, in moving, how express and admirable, in action, how like an angel, in apprehension, how like a god.
It is the struggle itself that is most important. We must strive to be more than we are, Law. It does not matter that we will never reach our ultimate goal. The effort yields its own rewards.
Let's go! 12, 11, 10, 9, 8, Let's rock and roll!
6.
Greetings mga ka-spacers, and welcome to this episode of Space, the Final Frontier. This is your ka-spacer, Professor June Cajigal. Now, Space, the Final Frontier is a series of online lectures that is intended to inspire our students out there to love the sciences, especially astronomy. Now, this episode of Space, the Final Frontier is entitled A Cosmic Perspective. Now, what do we mean by that? Now, the cosmic perspective flows from fundamental knowledge, but it's more than just what you know, mga ka-spacers. It is about having wisdom and insight to apply that knowledge to assessing our place in the universe. So I hope you would stick around and watch this special episode on a cosmic perspective so that you will know our place in the universe. So if you have any questions later or comments or reactions for this online lecture, please feel free to type in your comments, your reactions, and your questions in our comment section below. Huwag kayong mahiya po, and I will be very happy to answer all your queries. So tara na, and let us go where no man has gone before. Hello, greetings mga ka-spacers. So probably to introduce this topic for tonight about a cosmic perspective, I want you to reflect on the following. Now, across the centuries, cosmic discoveries have demoted our self-image. The Earth was presumed to be astronomically unique until astronomers learned that the Earth is just another planet orbiting the Sun. Then we presumed that the Sun was also unique until we learned that the countless stars of the night sky are actually suns themselves. Then we presumed our galaxy, the Milky Way, was the entire known universe until we established that the countless fuzzy things in the sky are other galaxies, dotting the landscape of our known universe. So mga ka-spacers, so what do we really mean by our cosmic perspective? Now, when we think of cosmic perspective, this is having the wisdom and insight to apply that knowledge to assessing our place in the universe. So the question now, mga ka-spacers, is what is our place in the universe? So to answer that question, let's take a look first at our own planet Earth and see our place as far as the Earth is concerned. Now, our planet obviously is the place where we all live. And planet Earth is comprised primarily of rock. The Earth is one of the rocky planets together with Mercury, Venus, and Mars. And our planet is spherical in shape, though our planet is not really a perfect sphere. Our planet is an oblate spheroid, meaning that it is flattened at the poles and it is bulging at the equator. And in terms of diameter, our planet is about 12,700 kilometers in diameter. So, come to think of it, malaki po yung mundo natin as compared to us. Para lang po tayo mga speck of dust as far as the size of the Earth is concerned. And with that, it would take 17 days to circumnavigate the globe driving a car at 100 kilometers per hour. So ganyan po kalaki ang mundo natin as compared to us. Now, isn't that fascinating mga ka-spacers? And to give you again an idea of the size of our planet compared to us, at the speed of light, it would take about 0.13 seconds to go all the way around the Earth. So kahit ganong kabilis ang ilaw or speed of light, it would still take 0.13 seconds to go all the way around the Earth. So ganyan po kalaki ang mundo natin as compared to us. Now, let's take a look at the so-called Earth-Moon scale. So let's compare the size of the Earth and our moon. Now, here is a photo of the moon superimposed with an image of our country, the Philippines. Now, this is in scale, and this was made by one of the co-founders of the Manila Street Astronomers, Mr. Norman Marigsa. So if you will notice, mas malaki pa talaga ang moon as compared to our country, the Philippines. And if you will take a look at Luzon, mas malaki pa ho yung Sea of Tranquility kung saan po naglanding yung Apollo 11 as compared to Luzon. So that's our country in comparison with our moon. So again, this photo was made by one of the co-founders of the Manila Street Astronomers, Mr. Norman Marigsa. And it would take about 4 moons to fill the diameter of the Earth. Now, the moon is about 3,476 kilometers in diameter. That's about a quarter of the diameter of the Earth. And it would take about 4 moons to fill the entire diameter of the Earth. So mga ka-spacers, let's take a look now at the distance of the moon from the Earth. Now, the moon is about 384,000 kilometers away from the Earth. Now, to help you visualize that distance of 384,000 kilometers, I want you now to zoom in on this photo of the Earth taken by the Apollo 8 astronauts as they orbited the moon. So you could imagine how far the Earth is from the moon. In fact, the Apollo spacecraft took about 3 days just to reach the moon. And here is a diagram of that distance of 384,000 kilometers. So the Earth and the moon in scale. Now, to help you visualize that distance, I want you to imagine this. Now, if the Earth were a basketball and then the moon would be a tennis ball, and that distance of 384,000 kilometers would be about 23.5 feet away. So that basketball and that tennis ball would be about 23.5 feet away. So that's how we imagine the distance of the Earth and the moon. If the earth were a basketball and then the moon would be a tennis ball, then that distance of the earth and the moon would be about 23 feet away. So isn't that mind-boggling, mga ka-spacers? So to add, mga ka-spacers, to this mind-boggling and jaw-dropping perspective of the Earth-Moon scale, I want you to think about this. So that distance of 384,000 kilometers would fill about 30 Earths. Yes, you heard me right, mga ka-spacers. So the distance of the Earth and the Moon of 384,000 kilometers would fill about 30 Earths. So isn't that fascinating, mga ka-spacers? And here is a photo of the sun together with the earth and the moon, and that is in scale. So you can imagine the distance of the earth and the moon compared to the size of our sun. And to top it all, mga ka-spacers, so imagine this, that distance between the earth and the moon of 384,000 kilometers is so big that you could fit every planet of the solar system between them, including Pluto, though Pluto is not really a major planet, but you could fit Pluto between the earth and the moon. So Jupiter, Neptune, Mercury, Venus, Uranus, Mars, Saturn, and let's include Pluto, though Pluto is a dwarf or minor planet. So all of them could fit in that distance between the earth and the moon. And what is so amazing, mga ka-spacers, is that there is still 2,092 kilometers to spare. So that's the distance between the earth and the moon. So every planet in the solar system, let's include Pluto. So again, Pluto is not a major planet. All of them could fit in that distance between the earth and the moon. So isn't that fascinating indeed? Now, to help you deepen your perspective of the so-called Earth-Moon scale, let's try to answer this question. So what would we see if the planets replace the moon? So I want you to take a look and reflect on the following photos, and by looking at those photos, let's try to develop that perspective if the planets would replace our own moon. So let's take a look at this photo of Mercury. If Mercury would replace our moon, then that would be our perspective of Mercury with the distance of 384,000 kilometers away from the Earth. Alright, so that's our perspective of the planet Mercury. And here is a photo of Venus. So try to imagine if Venus would replace our moon, then that would be our perspective of the planet Venus. Alright, here is a photo of Mars if Mars would replace our moon. And here is a photo of the mighty Jupiter. If Jupiter would replace our moon, then that would be our perspective of Jupiter. So, abot kamay na natin ang planetang Jupiter, even the Great Red Spot. So, abot kamay na natin ang Great Red Spot ng Jupiter if Jupiter would replace our own moon. Here is a photo of Saturn and its magnificent ring system. If Saturn would replace our moon, then that would be our perspective of Saturn at that distance of 384,000 kilometers away from planet Earth. Here is a photo of Uranus. And here is Neptune. If Neptune would replace our own moon, then that would be our perspective of the planet Neptune. Now, probably many of you might wonder, how did they measure the distance of the moon from the Earth? Now, many of you may not know this, But the Apollo 11 astronauts have brought with them this device, and they were able to install this on the lunar surface. These are the so-called retro reflectors. And here is a photo of that single retro reflectors. So they use this to measure the distance of the Earth and the Moon. So how? Now, astronomers measured the distance between the Earth and the Moon with unprecedented accuracy by firing short pulses of laser light on those retro reflectors or special mirrors that was installed by the Apollo 11 astronauts on the lunar surface. And by measuring the time it takes for the pulses to return to Earth, they were able to measure the distance between the Earth and the Moon. So mga ka-spacers, that's how they were able to measure accurately the distance of the Moon from the Earth. So by firing short pulses of laser light onto those special mirrors or retro reflectors that was installed on the lunar surface by the Apollo astronauts, and by measuring the time it takes for the laser to return to Earth, they were able to compute accurately the distance of the Moon from the Earth. And with that distance of 384,000 kilometers, it took the Apollo spacecraft 3 days just to reach the Moon. So ganyan po kalayo ang ating buwan. It took the Apollo spacecraft 3 days just to reach the Moon. And for your information mga ka-spacers, the Apollo 11 lunar module landed on the Moon using a computer that had 1,300 times less computing power than your iPhone 5S. So ang ibig lang sabihin niyan ay mas mabilis at mas malakas pa ang inyong cellphone as compared to the computing power of the Apollo spacecraft that enabled them to land on the Moon. So isn't that fascinating mga ka-spacers? Now, before we end with this discussion of the Earth-Moon scale, I'm sure you are all aware of the fact that the Moon revolves around the Earth in an elliptical path. So that means that there are times wherein the Moon is really close to the Earth, and we call that the lunar perigee. And there are times wherein the Moon is really far from the Earth, and we call that the lunar apogee. Now, at maximum perigee, the Moon is really close to the Earth, and the effect of that is that the Moon looks slightly larger. And this astronomical event wherein the Moon is at its maximum perigee is what we call a supermoon event. So isn't that fascinating mga ka-spacers? So before we continue with our discussion on a cosmic perspective, let's watch this fascinating video about the Earth-Moon scale. Alright mga ka-spacers, let's watch this.
Hello, we're going to create a scale model of the Earth-Moon system. Now, if you're not familiar with scale models yet, a scale model is something where we take each piece in the system and we reduce it the same exact amount. Now, that also means that we have to reduce the space in between the pieces that same exact amount. So let's start with a scale model of the Earth. You've probably seen a globe. This is a standard 12-inch classroom globe, and it's a scale model of the Earth. Now, the actual Earth is 8,000 miles wide. Well, this scale model is 42 million times smaller than the real Earth. Now, if this is how big the Earth is going to be in our model, think about how big you think the Moon will be in our model. Is the Moon bigger or smaller than the Earth? You can start there. All right, what if I told you that the Moon is 2,000 miles wide? That's less than 8,000 miles wide, So the moon is smaller than the Earth. Now, using those two numbers, you could actually get a rough idea of how big the moon would be. Let's do a little bit of math. So 2,000 miles wide for the moon and 8,000 miles wide for the Earth. Well, if you've got 8,000s, we can use our fingers, and the moon is 2,000 miles wide, how many groups of 2 can you get out of those 8,000s? I'll give you a second to think about it. How about 4 groups of 2? So what that means is that the Earth is 4 times wider than the moon. Or that means we could put 4 moons next to each other to match how wide the Earth is. So now, how big do you think our moon model is going to be? If you want to try some more math, remember I said that this is a 12-inch globe? Divide that by 4, or think about what number would you have to multiply times 4 in order to get 12? It's actually 3. We would need a 3-inch ball, which is about the size of a baseball. Now, if this is going to be a scale model, not only do we have to reduce each piece the same amount, we also have to reduce the size. So how far do you think we should place the moon from the Earth in our model? Do you think it would be here? That would be kind of cool to be able to reach up and touch the moon, but we can't. All right, what about here? Does that look right? In fact, that's around where most people tell me they think our moon model should be. But doesn't that kind of seem like we could fit another Earth in between? So that would mean that the moon is 8,000 miles away from the Earth. Does that sound right? No. In fact, it's way more. It's 238,000 miles from the Earth. So if we could fit 2 Earths in between, that would be 16,000. Are we there yet? No, we're not even close. I think maybe I could stretch my arms wide enough to fit 4 Earths in between, but we need more than that. I'm going to show you how far we have to put the moon away from the Earth in our model. It turns out that we can fit 30 Earths in between the Earth and the moon. So let me show you where we have to place the moon model in our scale model of the Earth-Moon system. Here, this is now a scale model of the Earth-Moon system. We've reduced the size of each piece 42 million times smaller than the real thing, and we reduced the distance 42 million times smaller than the actual distance. Now let me show you something from the Earth's perspective. Because this is a scale model, when we view the moon from the Earth's position, that actually shows us how big the moon would appear in the real sky as viewed from the real Earth. Does that seem smaller than what you would expect? Most people say that. But try this. Take a pencil and hold it at arm's length and put it up near where you see the moon in the model, and you see how it's a little bit bigger than what we're seeing for the model moon? Well, try that outside in the real sky. Your arm out at full length, pencil eraser, compare the size to the real moon. See if it works for you. Hopefully this helps you to understand more about the Earth-Moon system.
So mga ka-spacers, isn't that fascinating about the Earth-Moon scale? So at this point, let us now study the so-called sun Earth scale. So to give you that perspective of the Sun-Earth scale, let us consider the following. So our Sun is actually a star that the Earth orbits. And in terms of its composition, our Sun is composed primarily of hydrogen and helium. And in the interior of the Sun, nuclear fusion occurs. In nuclear fusion, hydrogen fuses to form helium. And in the process, the Sun generates heat and light to allow itself to resist the crushing weight of its own mass. The Sun is spherical in shape, and in terms of diameter, our Sun is 1.39 million kilometers in diameter. So what does that mean? Now, in our perspective, as compared to our Earth, the Sun's diameter is 109 times greater than that of the Earth. So that means, mga ka-spacers, over 1 million Earths can fit inside the Sun's interior. So that's our perspective of the size of the Sun compared to the Earth. Over 1 million Earths would fit inside the Sun's volume. And mga ka-spacers, it would take 11,780 Earths lined up side to side to bridge the distance between the Sun and the Earth. So to help you deepen your perspective of the Earth-Sun scale, let's take a look at the following photos. So here is a photo of the Sun and the Earth. So if you will notice, the Earth is just a small white dot against the black background of space, and compare that with our Sun. Here is another photo of the Sun with the Earth and the Moon. So if you will notice, the Earth is just a small black dot against the yellowish background of our Sun. So talagang malaki ang araw as compared to the Earth. And here is another photo of the Earth as compared to the size of the Sun. And for many amateur astronomers, we usually observe the Sun through our telescopes, and we observe usually sunspots. Now, these sunspots are even bigger than the Earth. So here is a photo of a sunspot, and compare that to the size of the Earth. So these sunspots are actually much bigger than our planet. So isn't that fascinating, mga ka-spacers? And here is a photo of the Earth, compare that to a solar flare. So talagang malaki ang solar flare as compared to the Earth. So isn't that fascinating indeed? And you might think that our Sun is unique, but there are other suns or other stars that are much bigger than our own Sun, like Sirius, Pollux, Arcturus, and in this photo you have Betelgeuse, or popularly known as Betelgeuse. So talagang malaki ang Betelgeuse as compared to our Sun. Our Sun is like a speck compared that to Betelgeuse. So are you not fascinated by that, mga ka-spacers? So before we continue, let's watch this interesting video about the Sun-Earth scale. Alright, mga ka-spacers, let's watch this.
Have you ever wondered about the scale of the solar system? So imagine this soccer ball, the football here, represents the Earth. How big would the Moon be on this scale? About as big as this tennis ball. So the Moon is about a quarter of the diameter of the Earth. And how far apart would they be? About that far. And how big would the Sun be on this scale? Approximately twice the size of the houses in the background over there. It wouldn't be able to fit in the gap between the Earth and the Moon. In fact, it's over 3.5 times larger than that. And on this scale, it would be approximately 2.4 kilometers, or about 1.5 miles away. The Sun is pretty big.
So mga ka-spacers, isn't that fascinating about the Sun-Earth scale? So let us now zoom in on the scale of the solar system. How big really is our solar system? Now probably you have seen pictures or illustrations of our solar system from the internet, like the one here in the picture. And in this picture of our solar system, the sizes of the planets may be in correct proportions, but the distances of the planets are all wrong in this photo of the solar system. So to give you the proper perspective of the distances of the planets, let's take a look at the following. Alright, so the distances in the solar system may take quite a bit of getting used to. So we have here the orbits of the inner planets, Mercury, Venus, Earth, and Mars. And we have here the orbits of the outer planets, Jupiter, Saturn, and beyond Saturn, we have Uranus and Neptune. Alright, and here is a photo of the Earth as seen from Mars. This photo of the Earth was taken by the Curiosity rover. So isn't that fascinating, mga ka-spacers? Look at the Earth. This is seen from Mars, and again this photo was taken by the Curiosity rover. And we have here a photo of the Earth as seen from Saturn. This photo was taken by the Cassini space probe. So to help you deepen your perspective of the distances of the planets, let us compare the solar system to Beda University, Manila. So here is an aerial view of Beda University, Manila. And at the center of the photo is the conference hall of Beda University. And this purple circle represents the orbit of Mercury. And this yellow circle represents the orbit of Venus. And this blue circle represents the orbit of our planet Earth. And this red circle represents the orbit of Mars. So, if you will notice that the inner planets, they are still within Beda University, Manila. Alright, and this orange circle, which is now beyond the university, represents the orbit of the mighty Jupiter. And you will notice that there is a big gap between Mars and Jupiter. So this gap represents the area where you would find most of the asteroids. So this is what we call the asteroid belt. Alright, now this yellow circle, which is really beyond Beda University, represents now the orbit of Saturn. And as we continue, this blue-green circle represents the orbit of Uranus. So as you could see, palayo na tayo ng palayo sa Beda University. Alright, and this blue big circle represents the orbit of Neptune. And beyond Neptune, this is the Kuiper Belt area where you would find Pluto, Aries, and Makemake. So that's how big our solar system is. This is to give you an idea of the proper perspective of the size and distances of the planets. So isn't that fascinating, mga ka-spacers? So mga ka-spacers, to help you deepen your perspective of the relative distances of the planets in our solar system, let's watch this very interesting video about the scale of our solar system. So are you ready, mga ka-spacers? Let's watch this.
If you look up an image of the Earth and Moon, you're going to get a picture where they're quite close together. Something like that. But in reality, the Earth and Moon are about that far apart. That is the Earth and the Moon to scale. Taking the same concept, but for the solar system, every single picture of the solar system that we ever encounter is not to scale. If you put the orbits to scale on a piece of paper, the planets become microscopic and you won't be able to see them. There is literally not an image that adequately shows you what it actually looks like from out there. The only way to see a scale model of the solar system is to build one. Welcome to Black Rock Desert. This is Alex. I'm Wiley. He's going to be behind the camera. I'm going to be probably making a lot of mistakes on camera. We have 36 hours to measure the distances, trace out the orbits, and set up a time-lapse shot from up on top of a nearby mountain. To create a scale model with an Earth only as big as this marble, you need 7 miles of empty space. So that's why we're here. Why did you guys come?
I don't have a job.
At this scale, the sun is 1.5 meters, so about that big around. So we are driving right now to Mercury, and we've arrived. Venus is the same size as Earth. I have the world in my pocket somewhere. And Earth. And this is Mars. Got a couple of robots rolling around on that one. Once the time-lapse is ready, we'll drive each orbit with a light. Hopefully you'll be able to tell just how big they really are. Onward to the outer planets. Jupiter. Saturn. That tiny light out there is our sun, just over 1 mile away. The sun's way, way out there now. This is it. This is the edge of the solar system.
So right now it's about 7 a.m. We just woke up right before the sun's about to rise. We are on the Earth's orbit. Wiley is over there holding our sun. Cue the dramatic sunrise music.
So if we've made our model correctly, your perspective from where Earth is on the model will match your perspective from standing on the real Earth. So if you look back at the sun, you will see that the model sun and the real sun are the exact same size. And that's how you can tell that the proportions are correct. There are 24 people in the entire history of the human species, billions of people, who have actually seen the full circle of the Earth with their own eyes.
Following the breakfast, the astronauts went to the suit room where they donned their spacesuits.
This is man's attempt to get to the moon.
0. We have liftoff. Liftoff at 7:51.
In Earth orbit, the horizon is just slightly curved. When you head on out to the moon, that horizon slowly curves around and upon itself, and all of a sudden you're looking at something that is very strange, but it is very, very familiar.
Oh my God, look at that picture over there. Wow, is that pretty?
You can put your thumb up, and you can hide the Earth behind your thumb. Everything that you have ever known, all behind your thumb.
Not any bigger than that, way up there.
It's really beautiful. You can cry.
That's what I really wanted to try and capture. We are on a marble floating in the middle of nothing. When you sort of come face to face with that, it's staggering.
So isn't that fascinating, mga ka-spacers, of the scale of the solar system? I hope that video had given you the proper perspective of how big really is our solar system and the relative distances of the planets. Now, to continue with this, did you know, mga ka-spacers, that it would take 8 minutes for sunlight to reach planet Earth? So, ganyan po kalayo ang mundo natin sa araw. It would take 8 minutes for sunlight to reach Earth. And it would take 330 minutes, or that is equivalent to 5.5 hours, for sunlight to reach Pluto. So, ganyan po kalayo ang Pluto sa araw. And if you are a Mars astronaut, or let's say for the Perseverance rover, it would take 13 minutes and 51 seconds for a one-way radio signal to reach planet Earth. So ganyan po kalayo ang Mars sa mundo natin. So a one-way radio signal from Mars would take about 13 minutes and 51 seconds to reach planet Earth. So for example, the Perseverance rover is now on the planet Mars. So the rover will take about 13 minutes for its signals to reach mission control. Then mission control would send signals back to the rover. That would take also 13 minutes. So roughly you have 26 minutes for radio signals to travel to and from Mars. So ganyan po kalayo ang Mars sa planet Earth. So mga ka-spacers, with this time delay of 26 minutes, this would give you an idea of how far Mars really is. And also to give you the proper perspective of the distances of the members of the solar system, let's take a look at the mission of the New Horizons space probe. The main objective of the New Horizons space probe was to encounter Pluto. It was launched on January 19, 2006, and it encountered Pluto on July 14, 2015. So mga ka-spacers, if you will count from 2006 to 2015, that's roughly 9 years. So even though the New Horizons was the fastest man-made space probe ever built by NASA, still it took 9 years for the space probe to reach Pluto. And that's really jaw-dropping and fascinating indeed. So mga ka-spacers, I hope this mission of the New Horizons space probe would give you the proper perspective on how far really Pluto is from the Earth. Again, it took 9 years for the New Horizons to reach Pluto. Now, let us also consider the mission of Voyager 1 and Voyager 2. Now, Voyager 2 was launched earlier on August 20, 1977. This was followed by Voyager 1 on September 5, 1977. Now, after its flyby to Saturn, Voyager 1 went out of the solar system. Then Voyager 2 continued with its grand tour of the outer planets of the solar system, visiting Jupiter on July 9, 1979. Then it visited Saturn on August 25, 1981. It also visited Uranus on January 24 of 1986. And it visited Neptune on August 25, 1989. Then after its flyby to Neptune, Voyager 2 went out of the solar system. And here is a picture of our planet Earth as seen by the cameras of the Voyager space probe beyond the orbit of Pluto. And this was known as the pale blue dot, as described by Carl Sagan. So, to continue, let's watch this fascinating video about the pale blue dot by Carl Sagan. Alright mga ka-spacers, let's watch this.
The two Voyager robots have explored 4 planets and nearly 60 moons. They are triumphs of human engineering and one of the glories of the American space program. They will be in the history books when much else about our time is forgotten. The Voyagers were guaranteed to work only until the Saturn encounter. I thought it might be a good idea, just after Saturn, to have them take one last glance homeward. From Saturn, I knew the Earth would appear too small for Voyager to make out any detail. Our planet would be just a point of light, a lonely pixel, hardly distinguishable from the many other points of light Voyager would see, nearby planets, far-off suns. But precisely because of the obscurity of our world thus revealed, such a picture might be worth having. While almost everyone is taught that the Earth is a sphere, with all of us somehow glued to it by gravity, the reality of our circumstance did not really begin to sink in until the famous frame-filling Apollo photograph of the whole Earth, the one taken by the Apollo 17 astronauts on the last journey of humans to the moon. It has become a kind of icon of our age. You can make out the blue of the ocean, the yellow-red of the Sahara and the Arabian Desert, the brown-green of forest and grassland. From this vantage point, our obsession with nationalism is nowhere in evidence. The Apollo pictures of the whole Earth conveyed to multitudes something well known to astronomers. On the scale of worlds, to say nothing of stars or galaxies, humans are inconsequential, a thin film of life on an obscure and solitary lump of rock and metal. It seemed to me that another picture of the Earth, this one taken from 100,000 times farther away, might help in the continuing process of revealing to ourselves our true circumstance and condition. It had been well understood by the scientists and philosophers of classical antiquity that the Earth was a mere point in a vast, encompassing cosmos. But no one had ever seen it as such. Here was our first chance, and perhaps also our last, for decades to come. From this distance, the planets seem only points of light, smeared or unsmeared, even through the high-resolution telescope aboard Voyager. They are like the planets seen with the naked eye from the surface of the Earth. Luminous dots, brighter than most of the stars. You cannot tell merely by looking at one of these dots what it's like, what's on it, what its past has been, and whether in this particular epoch anyone lives there. Because of the reflection of sunlight off the spacecraft, the Earth seems to be sitting in a beam of light, as if there were some special significance to this small world. But it's just an accident of geometry and optics. From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager. Every hero and coward. Every creator and destroyer of civilization. Every king and peasant. Every young couple in love. Every mother and father. Hopeful child. Inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings. How eager they are to kill one another. How fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
Well, I guess that's about it for this episode entitled A Cosmic Perspective. So after listening to this episode, I hope you would realize that we are just a speck of a speck of a speck in the vastness of the universe. And I hope the virtue, the value of humility is instilled after listening to this online lecture. I would like to thank the officers and crew of the BEDAN Society of Young Astronomers, and also I would like to thank the administrators of San Beda University Senior High School for supporting this organization. And I would like to thank you mga ka-spacers out there, yung mga avid followers namin. Thank you for watching this episode of Space, the Final Frontier. So sana wag po kayong magsawa at lagi kayong tumutok dito sa ating programang ito. At marami po kayong matututunan dito sa Space, the Final Frontier. So I guess that's about it mga ka-spacers. This is your ka-spacer and Space Commander Professor June Cajigal saying, live long and prosper, and I'll be seeing you soon. Stay safe, wear your face mask and face shield. Alright mga ka-spacers, goodbye everybody, and see you in our next episode of Space, the Final Frontier.
That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives.
It is a wonderful and astonishing thing to me that we are, you and I, are somehow at least one of the ways that the universe knows itself.
Those worlds in space are as countless as all the grains of sand on all the beaches of the Earth. Each of those worlds is as real as ours. In every one of them, there's a succession of incidents, events, occurrences, which influence its future.
We are special because we're the same. We are one, not only with each other, but with the universe itself.
I know Hamlet, and what he might say with irony, I say with conviction. What a piece of work is man! How noble it is, how infinite in faculty, in form, in moving, how express and admirable, in action, how like an angel, in apprehension, how like a god.
It is the struggle itself that is most important. We must strive to be more than we are, Law. It does not matter that we will never reach our ultimate goal. The effort yields its own rewards.
Nine, 8.
Let's
7,
rock and roll!
6.
Sound take you away. Last night I hold her, let him slip, and so I wish that I could stay.
seeing what's to come. The image of the dead ends in my mind.